So for our for case study number 3, one of the big points of this case study is to learn how to create hypotheses, test them, and then interpret them. So several weeks ago in one of the announcements, I gave you some examples. I used it as Wyoming and then within Wyoming, if I was using Wyoming, for example. And as a reminder, right, you are developing 4 sets of hypotheses. One-tailed test and two-tailed test. And that is because a two-tailed test essentially says that your hypothesis is a particular value or it is not. Those are your that's essentially what a two-tailed test is, right? And the reason is that if you have a normal distribution, right, that curve that we've been working with, and you're saying it is a value or it is not, then the reason for that is because it could be on either side of your mean and be wrong, or if it is that value, it's right. Meanwhile, a one-tailed test is saying that something is larger than or less than. If you need a visual of this, you can look at the lecture slides that I posted. You can also go back to your textbook, right? Those are really important resources for you to go back to in terms of the rationale between a one-tailed and a two-tailed test. I went through this in class. I'm revisiting it now, and then going back to those resources are really crucial. So this, I gave you an example if I was doing Wyoming, for instance, comparing it to the United States or within itself. So in this case, your one-tailed test is basically saying that Wyoming, and so the highlighted portion is what you can plug into your, like whatever you are changing. Wyoming, in this case, your state, mean rent is not less than the mean United States rent, and then Wyoming's mean rent is less than the mean United States rent. I'm noticing some folks still kind of having hiccups on this, and it's really important that you pay close attention. What I had said was that you have to always have a null hypothesis as a companion to your research hypothesis. Again, go back to those slides and that chapter of the textbook, which is chapter 8. Whatever you think is going to happen is your research hypothesis or your H1, and then then your default or the hypothesis of no impact, no effect, no difference is your null hypothesis. So for every hypothesis you have, you need to have a null hypothesis. Now, this highlighted portion, as I said, is what you're changing. So this would be your state, and then this is what you think is going to be the case. So for our one-tailed test, we're comparing our rent and our income to the United States. So if I was using Wyoming, for instance, I'd say Wyoming's mean rent is not less than the mean United States because I'm actually hypothesizing that it is less than. Whatever your state is, you're going to decide, do you think it's greater or do you think it's less? And you need to change that. This has to be the direct inverted type of this one. Okay, so it needs to be, they should not be different, except one will say not and one will say it is. Okay, you need to make sure you look at your hypotheses. And same thing for your income. These are your one-tailed test. Your two-tailed test are going to be your particular state only. So this first one is going to be comparing it to the United States, and then this two-tailed one are focused only on your state. So if I was doing Wyoming, right, whatever your state is, plug that in here. Whatever I think is the mean rent is this hypothesis, but then my null is going to say that it's not that value. The reason it's a two-tailed is if it's less than this range or greater than this range, then that's what you're testing essentially. Okay. So again, you're just going to change this. And then where I got this from was directly related to the categories that are here. Make sure your categories are correct. Make sure they reflect exactly what I have here. This is where I got my categories from. And that's where I got that value from. So I plugged that directly in here, and it's only for my state, not comparing it to the United States. And then the same thing for this. The reason is that we are going to be doing a t-test and a z-test, and one is going to be looking at that you have the population's values. So that in this particular case, then it means that Wyoming, we're assuming that Wyoming is a sample of our larger population of the United States. In this case, we're just saying that what we have is a sample, but we don't know the larger population's values. Okay. Okay. So then for your case study, and I'll share this document with you with the link in the lecture link. In here, you'll have your introduction. Remember that as a group, you needed to come up with an introductory statement, an explanation with outside sources. I would like them in APA format, please. And you'll want to have a works cited page. Then you'll go into your data and you'll paste your tables. I don't have all of these filled out. You do need to have them filled out. Please make sure you have those filled out. Right, I pulled from my table. Now, it can't fit this one here. I'm not particularly picky with that. But you'll need to make sure you at least have this column here, but you need to make sure you paste your table in. Um, the table should be filled out and calculated. So I'm going to go through and remind you how to get to that point because you need to have your mean. And I've gone through this several times. So I'm going to go through it pretty quickly. Because again, we've done this is our third case study doing this. And I've gone through it in class multiple times. So remember that it's the sum of your f times your y divided by your n. Because this is ordinal, you assign it a y value, right? So I assigned it this y value. And what I've done was I've multiplied that y value times its respective frequency on the same line, which is how I got this here. But because it's the sum of it, I added it all up. And then I divided it by the total of my frequency, which is how I got my mean of 4.14. What that tells me is that because I round it to 4, that this is my mean category, right? And so that's why I have this written here and I have the mean next to it. My standard deviation and also these formulas that are all here, I've given them to you on the board. They're in your textbook, they're in the slides. We've gone through them multiple times, so just make sure you go back to your either your photos, since I know a lot of folks take photos, or your notes, so that way you have those formulas down. So your standard deviation is the sum of your y minus your mean squared, divided by n minus 1. But in this particular case, because we've converted it now into mean categories, n minus 1 is going to be the number of categories you have. So that's why I have my y minus my mean. So I've subtracted 1. I've taken 1 minus 4.14, 2 minus 4.14, etc. And I've gone through. You also can always use the formulas that I have in the bars up here as a reference point to see what I'm doing and where I'm pulling from. Okay, so now I've squared them, right? Making sure that you use the headers as like hints. I've squared them, right? So this is this value squared. They should all be positive values. Please pay close attention to that. And then I've added them up because adding them up is the sum of my y minus my mean squared. What I've done was I've taken this and I've divided it by n minus 1, so 7 minus 1. I take the square root of all of that, so this divided by 6, and the square root of that, which gave me my standard deviation, a 2.16. Your standard deviation shouldn't be more than 3 at this point, but if you have something that's just a little over 3, that might be acceptable, but you just want to pay close attention to that. If not, it's very possible that you did not take the square root, especially if it's 4 or over. Z-scores is just your y. So all of these here, your y minus your mean, divided by your standard deviation. So I took this right here and divided by my standard deviation, and that's what gave me this here. Then I go into the back of the textbook, into Appendix B. So you're going to go into Appendix B right here, and you're going to look for your Z-score. As a reminder, this column A is where you'll find your z-score. You will never find a negative because the negative and positive values are exactly the same. So you don't ever have to worry about those. You just are going to find those values. The difference between the negative and the positive is just simply that it's below or above the mean, right? These are negative, they're below the mean. These are positive, they're above the mean. So you're going to find those values when you put them in here. And as a reminder, the mode is just the one with the highest frequency or the highest percentage. So if you can just kind of take a quick glance at this and you can see which one is your mode. Okay, so like I said, I didn't want to go through too much on here. With this one down here, you're going to find your percentage distributions, right? So just like all of the others, you're going to press equals and click on it, that frequency divided by your total. We've done this a bunch of times. Go back into your past case studies, go back into any of the notes or examples that I've provided over the last couple of weeks. And so that's where you're going to do that. As a reminder, though, for your squared values, you cannot click on it, right? Oh, sorry, excuse me. You cannot click on it. You have to actually type it in. So 62, so in this point, 62.71 squared. You have to type it in. We're just doing IQV. IQV should always be between 0 and 1. And so because of that, you are going to take the sum of your percentages squared, which is this value, um, and you're going to plug it into that formula, right? Which is K, or the number of categories that you have, times, in parentheses, 100 squared minus the sum of percentages squared, which is this. Do not square it again, because this is the sum of your percentages squared, divided by 100 squared times K minus 1. That's the formula that you're using. Go back into those formulas that I've either put that I put on the board, you've taken photos of. Again, go back to your textbook or the lecture slides as well. Okay, so that's where we're at with this table. And now at this point, what happens is you are going to start looking at the calculations um, for your hypotheses testing. So you'll see underneath my table, I have just kind of a quick interpretation. You will also want to interpret this here, which is what I have in this example. Please note, you are not only doing one just because I only have one here. You need to go through and do all of them, at least for column B. So you need to do all of your interpretations for column B so you get into the habit. This will be the last case study that we're doing all of those interpretations, but so that way we have an understanding of them. Case study 4, we won't have to do each of those interpretations, but it is important that you are doing it for all of them. Just because, again, I have one example does not mean that you are only doing one. Okay, so I have my hypotheses written out. And remember that there's different reasons that you would use a t-test or a z-test, right? A t-test is something that you can do if you don't know the population's value, while a z-test requires that you do know the population's values. So I have my two-tailed, and I'm saying that, and I'm using it based off of just my United States data. And I'm saying I conducted a t-test to test this hypothesis, right? And so I'm using the t-test for this two-tailed hypothesis and a t-test for this one-tailed hypothesis. Um, and what I'm doing is I'm using, um, I'm using um, income. Uh, I'm using the values from my data in order to run this test, right? Okay. So the very first thing that we have to do is we have to come up with our T. Oh, I deleted that. T critical. Okay. Oops, that should be T critical value comes from the back of our textbook, and you have to calculate your degrees of freedom. So degrees of freedom is just N minus 1. If you look at this here, it's from Appendix C. You have to remember that we're doing two-tailed tests for our rent and income. And not because we're doing the t-test for our two-tailed, not because it's a two-tailed test, but because we simply don't have all of the values for our population values. Okay. I want to make it very clear that you are doing this for income and rent. I'm just giving you one example to go through here. Okay. As we're going through. So this information will look exactly the same, but for rent down below, as it relates to your table under rent, I'm just giving you the example through income because I want you to try to go through and do it yourself for the rent. So I have my two-tailed hypothesis for income and my one-tailed hypothesis for income. And I explain what each of these are. So my T critical value for income is N minus 1. So I know I have 7 categories minus 1, which is 6. That is what our degrees of freedom are. So what happens is you go into this textbook and you go to the two-tailed, because that's what we're doing for this, is we're looking at a two-tailed test, right? We are conducting a two-tailed test for this right here. Actually, it would be better for this to be up here. Okay, so I'm doing a two-tailed test, and as a reminder, our alpha, our alpha value is always going to be 0.05 for the purpose of this class. It can be 0.01, it can be other values, but for the purpose of this class, it's 0.05. That basically measures our level of statistical significance. So you're going to use this here, and you're going to go to 0.05. everybody's degrees of freedom are the same, but for income, I'm looking at degrees of freedom of 6.05. Okay, so this is my T critical, 2.447. All right. What that means is when we calculate our T statistic, that the T statistic is going to be compared to our T critical. Okay. Now, this is where we're going to go in and we're going to calculate our values based off of this formula. Okay. All right. So this is our t-test. T equals the mean minus our mu divided by the standard deviation divided by the square root of n. Okay. Now this bottom part here is called our standard error. All right. Um, and because we're working with values that we don't quite know the full scope of yet, what happens is, oh, you'll also have to have your standard deviation written here too. In this particular case, it's 2.16. Okay. So in this particular case for our t-test, what we're doing is we're plugging in values. So this right here is our actual calculated mean. So for me, that's going to be 4.14. So 4.14. Now, what this value right here is, this mu, is our hypothesized value. So if my hypothesized value is 40,000 to 59,999, I'm going to go up and look at it. Okay, so I'm actually hypothesizing that it's this value. So I'm going to plug 3 in there. Okay, so 3 is because that's the Y value that I've assigned that range. Then I'm going to take my standard deviation that's in here. In this particular case, it's your standard deviation. So mine is 2.16. Yours is going to be different. Divided by the square root of n. All right. Or in this particular case, it's going to be the square root of 7. Okay. So that now becomes what I'm trying to run my calculation on, right? Now I'm going to plug that in. Like I said, Desmos can be incredibly helpful. I did ask folks to already calculate their standard error, but at the same time, not everybody did. So you're just going to go, you can just go into Desmos because it's helpful to do that. And make sure you are using your right orders of operation because, right, sometimes it'll be funky. And maybe like plug in the wrong thing, right? So in this particular case now, my T statistic is 1.396. Okay. So that's what my value is now. That is my T statistic is 1.396. Okay. So I'm going to delete all of this work here. So, pause the video, take a photo of it, do what you need to do. And that now is going to give me 1.396. Okay. So what you do is your T statistic now is going to be compared to your T critical. All right. So in this case, if your T statistic is like your T statistic, this whole value, even if it's a negative, it's the absolute value. So just ignore the sign basically. If your T statistic is larger than this value, that means that you will reject your null hypothesis. If this is less than, you will fail to reject your null hypothesis. So in this case, I would write, because the T statistic is less than the T critical value, I fail to reject the null hypothesis. Okay. All right. Now, one of the things that you're going to see what that means, though, is it means that if I fail to reject the null hypothesis, right, that means that my hypothesis is wrong. In my particular case, it makes sense. In my particular case, it makes sense. I failed to reject the null hypothesis because if you look at this, this is my mean, right? Failing to reject the null hypothesis means that I am saying that this is the one that is correct. So that's what I'm going to write is because I failed to reject the null hypothesis now. Um, and that's all you have to do for that. You're going to do that twice, right? Once for income, once for rent. Now, your one-tail hypothesis is using a z-test. The formula is very, very similar. We actually can take that out. All right. So in this case, oh, actually, you're also going to want to put up here too, alpha is set to 0.05. That way you know what you're doing, right? All right. So for my one-tailed test, I'm using a z-test. The z-test is formula is incredibly similar, but the interpretation is different. So in this particular case, formula is very similar, as I mentioned. All right, you're going to notice, right, that this right here is our symbol for sigma, which stands for our standard deviation. I mean, yeah, our standard deviation, but specific to our population. So up here, the one before, you're using your standard deviation. In this case now, you're using my standard deviation of the United States. Okay. So this right here is your mean that you've calculated, and this is what the population's mean is. In this case, my mean, the United States mean. So this is what your actual how calculated value is. This is the United States value. This is also the United States value, which is my United States mean. Okay. Now, my one-tail hypothesis phrasing is a little different because I just did the United States, right? I calculated the United States, but yours is going to say the United States. And so whatever that value is what you're plugging in here. So if you're saying that it's greater, that the mean United States value is this right here, for this mu, this fancy M mu, you're plugging in the value of 4.14 actually, because that's what the population's value is. Now, in this case, I'm just going to go through and pretend that I'm doing it the same way. So Y bar, right, whatever my actual mean is, well, whatever this, my actual mean is 1.14. So I'm going to do 4.14. My bad. I apologize. And my hypothesized value for you, it's the mean United States value. That's what you're doing. Okay. So in this case, your mu is going to be 4.14. Please, please, please make note of that. Your mu for your z-test is 4.14. I'm giving you an example of the greater than or not greater than value calculation. So for me, I'm going in and I'm going to look at, okay, well, that's 5 because that would have been category 5. Again, for you, you're putting in 4.14. All right, my standard deviation is 2.16. Again, you're going to calculate, you're going to put in 2.16 as well, because that's the United States information. So in this case, I'm going to do 4.14 minus my hypothesized value. All right, which gives me now I'm going to delete this. So please pause it if you have to take the picture. Gives me a value of negative 1 point. So Z statistic is negative 1.05. You're also going to want to put the alpha is set to 0.05. Okay. So this gave me a Z statistic of negative 1.05. I'm going to go into the back of the book now, and I'm going to go back to Appendix B, which we're familiar with now, right? Okay, so I'm going to go back into Appendix B, and I'm going to look up my Z-score. Why is this? I'm going to look up my Z-score now, right? So that's essentially what a Z statistic is a Z-score. So 1.05. All right, my Z is 1.05. So let's go find that. Okay, so this is where I'm at. Now, we're going to be using column C to run our calculation to have or to compare. So basically, this means that my calculation's p-value, okay, this equals a p-value. So my p-value comes from category from column C around my z-score, right? My z-statistic. So in this particular case, it's 1.4, sorry, 0.1469. If you had a two-tailed test, you would multiply this by 2. We do not. We have a one-tailed test. Now, what happens is we compare this to our 0.05. If your p-value is less than 0.05, you will reject your null hypothesis. If your p-value is greater than 0.05, you will fail to reject the null hypothesis. I fail to reject the null hypothesis. And basically, if I look at this, the mean United States rent will not be greater than this value. I fail to reject it, which means that my null hypothesis is correct for my particular data. It makes sense, right? Now, for some of you, you might not have that, and you might say, that's weird. There's a lot of reasons for it, where if you have one calculation and your hypothesis says that you're wrong, even though your calculations say otherwise, that might be a type 1 or type 2 error. Go into the lecture slides, go back into the book or the notes that I had mentioned around the type of errors, and type, I believe this to be a type 2 error. I believe this to be a type 1 error if you believe it is a type of error. I am asking that you try to do that, please, as you're going through, if you look at any kind of funky interpretations or calculations. Nonetheless, this is what I'm looking for in terms of the hypothesis testing. And you're just going to basically do this again for your rent. Okay. So you're going to do this again for your rent. Same thing. These need to be filled in. And then you'll have your IQV, right? IQV equals, in my particular case, it is 0.66. This means that of all the racial categories that could be selected, sorry, typo, could be selected with this population or the sample rather of people. They represent 66% of the possible racial differences. So that's what you're going to be looking at, right? And you're going to also talk about the mode. And then as a group, you're going to have your conclusion. So as a group, you need to look at the breakdown of race. You need to look at the breakdown of these different values and start making interpretations. Also, you need to, as a group, have the United States data at the very beginning. You need to, so you can just put, Dr. H's work up at the top before you get into all of your data. So like you'll have your introduction and then you'll have the data. You could put Dr. H, Dr. H, so I know that is mine and it's the United States, because at the conclusion, I'm looking for a detailed conclusion now to explain the patterns that you're seeing, the differences, and wrap it back up now with the introductory paragraph. The really important part of this is that you are not just looking at data, but you need to also look at the differences across the data. You also need to look at what could you potentially propose as some sort of like change, some sort of positive impact, right? Would you propose policy impact and change? Would you propose, like, what would you propose to make a difference when you're looking at the states compared to the United States and the conclusion statement? You also will want to compare your data briefly after, like, to the United States. So each of you independently. So after after you look at your family income, compare it to the United States, etc. So that's kind of what we're looking at with the hypothesis testing. You will be doing one more round of hypothesis testing for the next case study. So just make sure that you have a critical awareness and deep dive and understanding of the materials as you're going through before you submit this.